Hello everyone, Professor Vaibhav Shah here. Hope you have checked my previous lectures. If not, I insist you to go through that lectures first, which are containing basics of scales, types of scale, representative fraction or you can say RF, way to solve examples with some useful solve examples. In today's lecture number 5, we'll be solving some more examples based on concepts and tricks learned from previous sessions. If you like my content and teaching style, then share it with your friends and do not forget to like and subscribe to show your love and support. Let us start. Use following formulas for calculation in this topic. So first, representative factor or you can say RF equal to dimension of drawing upon dimension of an object. If your dimension is in the form of length, so it can be length of drawing upon actual length. If your dimension is in the form of area, it can be under root of area of drawing upon actual area of an object. If your dimension is in form of volume, then it can be cube root of your volume as per the drawing upon your actual volume of an object. Now, we need one more equation, which is length of scale is equal to RF into maximum length to be measured. So RF we can find out from the previous example or previous equation, and maximum length to be measured must be given in your statement, problem statement. The final answer, length of scale, is the length which we will draw in our actual drawing sheet as your length of scale. So these are two basic equations that you have to remember for any of the scale example, either of your diagonal scale or your plane scale. So now we need to remember one more thing, unit conversion table. So I believe that most of the examples in your examination will come from this table. So try to memorize this table. So I would just suggest you that you write down this table somewhere. So it will be great help for you. Now it seems too difficult to memorize this table, right? So I will be giving you a shortcut trick. So we'll be using this unit staircase. So here we can convert from your kilometers till your millimeters. And if we go from this shoe upward in this direction, we have to divide it by 10. And if we go downward from this shoe in the downward direction, we can multiply it by 10. So let us take one example. If you want to convert 1 kilometer into meter, so what we do is, so let us see. So we are here at the top. You can see the cat. So cat is sitting on the kilo. That means it is specifying 1 kilometer. And we want to reach 2 meters, which is down there here. So this is your meter, which is your base unit. It is specifying by shoe. So now if cat has to go from kilometers to meters, so it has to get down by 3 steps. 1, 2, and 3 steps. So it has to get down by 3 steps. So now one step is representing by 10. So if we get down by 3 steps, we will have to multiply it by 10 because we are getting down. So now 1 kilometer into 10 into 10 into 10. Why 3 times? Because we are descending by 3 steps. So if we find out the answer, we'll be having 1000 meters. So we can say that 1 kilometer is 1000 meters. So you can try and check for number of units, and you can be sure that you get mastery on this staircase unit conversion technique. So now let us start with today's example, problem number 1. The distance between two stations is 210 kilometers. A passenger train covers this distance in 7 hours. Construct a plane scale to measure time up to a single minute. Representation factor here is 1 by 2 lakh. Indicate the distance traveled by train in 29 minutes. So here the distance is given, which is your 210, and they are talking about the same distance which is covered by the passenger train. So our maximum distance would be 210, but here the distance is covered in some particular time. So we have 210 kilometers in 7 hours. That means our velocity or speed of the train is given. So we have to construct the scale. Keep in mind that kilometers as well as kilometers covered in particular duration of the time. So now we have to measure up to the single minute. So we'll be converting these hours into minute first to draw our scale, and RF is given. So we have to indicate on this scale 29 minutes. So we have to find out the distance traveled by train in 29 minutes. So let us start. So first 210 kilometers in 7 hours means speed of train is 30 kilometers. Why 30 kilometers? So we'll just divide 210 by 7. So it will give you 30 kilometers per hour. Now we are dealing with the single minute, so we'll be converting this hour into minute first. So this is your 1 hour is equal to 60 minutes. Now actual length of scale, which is equal to RF into maximum distance per hour. because we are dealing with the speed, so we'll take maximum distance per hour, so which is 1 by 2 lakh into 30 kilometers per hour. So we'll multiply it by 30. So now it is kilometers. So we must convert this kilometer into centimeter to draw our scale. So we'll convert these kilometers into centimeter. So we know that 1 kilometer is equal to 1000 meters. 1 meter is equal to 10 centimeter. 1 meter is equal to, 1 meter is equal to 100 centimeters. So we'll convert these 30 kilometers into centimeter. So now after solving this, we can have 15 centimeters. So we will draw one actual length of scale of 15 centimeter long. So let us draw one scale of 15 centimeter long. Now 15 centimeter length will represent here both things, 30 kilometer and 1 hour, because we are traveling 30 kilometer in 1 hour, so it will represent two things, 30 kilometer in 1 hour, but here we have to deal with the single minute. So that's why we'll be taking 1 hour as your 60 minutes. So we'll be denoting 60 minutes and 30 kilometer on this scale. Now draw the line of 15 centimeter long as we have drawn. Now we have to divide this line into 6 parts, because we have two different things, 30 kilometer and 60 minutes. 60 minute is your higher number, so 60 minute means you are having a significant digit as 6 in this case. So you will divide this line into 6 parts. Each part will represent 5 kilometers and 10 minutes. So let us divide into 6 parts, 1, 2, 3, 4, 5 and 6. So we have divided this line into total number of 6 parts, 1, 2, 3, 4, 5 and 6. After that, we will be drawing this vertical line of 10 mm, because we will get a vertical line of 10 mm for getting a proper look of scale. So let us give the 10 mm. After that, we will be dividing this first part into subdivisions. So we have divided the first part into 10 subdivisions. Now after that, we will specify this unit. So let us start specifying the unit. So we will start specifying the unit from the end of the first division from here. So place 0 somewhere here at the end of the first unit. After that, number the units on the right hand side, 0 to your primary scale. So we'll specify these in the units. So now we'll draw this as a minute scale. So we'll specify units in the tens interval, because we have total 60 minutes. So we have divided into 6 parts. So each part will contain 10 minutes. So this is 10 minutes, 10, 20, 10, 30, 10 more minutes, 40 and 50. So we have divided this minutes into interval of 10 minutes. So 10, 20, 30, 40 and 50. Now after that, we have subdivided this first 10 minutes into further 10 parts. So this is your 10 minutes. So this is also your 10 minutes. So let us divide this 10 minutes into further 10 parts. So this is showing 1 minute, 1 minute, 1 minute, 1 minute, 1 minute. So each of the divisions is showing 1 minute. So this is your total 10 minutes. So we have specified these as a minutes. Now let us specify kilometers here. So we have total 30 kilometers and we have divided this line into 6 parts. So divide 30 by 6. So we will be having 5 kilometers. So now we will divide the line into total of 6 parts of 5 kilometers interval. So 5, 10, 15, 20, 25. But remember, we are showing both the things, kilometers and time, on the same scale, which is a unique example in itself. Now we'll be further divided this for the portion into 10 equal parts. So this is representing your 5 kilometers. So that means this is also representing your 5 kilometers. Now if we are dividing this portion into 10 parts, that means total 5 kilometers by 10. So that means one single division will represent 0.5. So that means one single division will represent 0.5. So for these kilometers, this will be 0. This is 0.5, 1, 1.5, 2.5, 3, 3.5, 4, 4.5 and 5. So this will represent 0.5 divisions for your single line. So let us specify the units first. So now we'll specify these as a minute, because this is specifying your minute scales. This is specifying your kilometer scale. So let us specify. Now here it says that indicate the distance traveled by the train in 29 minutes. So let us indicate 29 minutes first. So for 29 minutes, we can separate it into 20 and 9 minutes. So 20 is your primary scale. So 0, 10 and 20, draw one vertical line, and 9 from your secondary scale, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 9 is your secondary scale. So this will specify you total 29 minutes. So this will specify you total 29 minutes. Now on the same scale, if you try to measure the distance on kilometer scale, so it can represent you total kilometers traveled in this 29 minutes. So let us see 0, 5 and 10. So it has traveled 10 kilometers here. And if we try to calculate here, so it is 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4 and 4.5. So this is your 4.5 kilometers and this is showing your 10 kilometers. So 10 plus 4.5 kilometers, that means the train travel distance in 29 minutes is 14.5 kilometers. So once again, we have drawn the same scale on which we have indicated minutes and kilometers as well. So first we have drawn the minute scale in bottom. So we have to find out for every single minute. So we have total 60 minutes. We have divided into 6 parts. That means a single part will represent the interval of 10 minutes. So this is 10 minutes, 20, 30, 40, 50. And we have further divided this into 10 equal parts. So 1 minute each. So this is specifying you 10 more minutes. Now after that we have specified the same kilometer on the same scale. So we are having total maximum kilometers of 30 kilometers. So now we have divided this 30 kilometers into 6 parts. So 30 by 6, that means you will be having 5 kilometers each. So we have divided this part into 5 kilometers each. So this is the interval of 5 kilometers. This is 5. So 5, 10, 15, 20 and 25. And we have further divided this first portion of 5 kilometers into further 10 parts. So this is your 5 kilometers divided by 10. That means one single part will represent 0.5 kilometers. So this is your 0 for kilometers, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5 and 5. So this is total your kilometers. Now we'll indicate the distance traveled by the train in 29 minutes. So now first let us denote the 29 minutes on this scale. So 29 means 20 plus 9. So we'll indicate 20 on this primary scale, 0, 10, 20. So we have drawn one vertical line of 20 minutes. And for 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll go 9 on your secondary scale. So we'll draw one line. So if you try to measure this distance on your kilometer scale, so it will represent from 0, 5 and 10, 10 kilometers on this side, and on this side it will represent 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. So it will represent 0, it will represent 4.5 on this secondary scale and 10 on the primary scale. So if we try to add this both of the terms, 10 plus 4.5, so we will be having 14.5, which is a total kilometer distance travel in 29 minutes by this scale. This is not a tricky example, but this is a combination of both examples in one single scale. So you need to pause this video and check once again. And if you have any doubt, any query, you can comment in the section below. So this was your example. So we'll specify the RF and plane scale showing kilometers and minutes. Okay. So now remember, to construct the scale, the data required is first the RF of the scale, second the unit which it has to represent, like millimeters, centimeters, meters or kilometers in the MKS, or inches, feet or yard or miles in FPS. Third, the maximum length which it should measure. If the maximum length is not given, some suitable length can be assumed. Fourth, actual length of the scale to be constructed on the drawing sheet, which can be found out by actual length is equal to RF into maximum length to be measured by the scale. So this is all from my side. Do not forget to share it with your friends and like and subscribe to show your love and support. Keep learning, stay connected, and if you have any doubts or queries, feel free to comment below. Bye-bye.